Day 4, area. So I would go through and highlight the area of these things. One of them being the area of a parallelogram. When you're doing a parallelogram or a rectangle, you always have to make sure you know where that 90 degrees is, because that 90 degrees will give you your height and your base. So looking at these first problems, I have this 90 degrees right here. So that means this would be my height. The other lengths help create the 90 degrees. That's your height and your base. So it'd be 8 times 10. So this answer would be 80 inches squared. Should do B. Now if I'm looking for the height, because technically you have two heights depending on your base. You look at these 90 degrees. This 90 degrees would be with this height and this base. Now this base is the same thing as this. So I can do 3 times 8, which would give me 24. That's my area, except I'm looking for my height, my other length. So in this 90 degrees, this would be my height. This is my base, because those two lengths, even though this is dotted, would give me my base. So these two are the same. So 4 times h would be equal to the area is going to be the same no matter which height you use in base. So if I divide by 4, h would be equal to 6. When you're dealing with a triangle, it's very important, again, to look for that 90 degrees. I'd highlight, if you don't already know, the area of a triangle. So the area of this first one, I'm going to do the first one, you're going to do the other two. Here's my 90 degrees. A lot of times people get this confused, but here's my height, because whatever makes up your 90. And then this whole length, it has to be a length of your triangle. So it's 1/2, because that's part of the formula, times your height, times your base. So my base is going to be 8 plus 5, which is 13. Which would be 39 feet squared. So what if I have irregular? So basically it's just saying you have two shapes either put together or else you have a shape taken out. I'm going to do A, you're going to do B. So what I'm first doing, I need to figure out what the height is of this. Now this length, sorry if I'm not going all the way, but if this is 12, this one has to be 12 right here because it's saying it's a rectangle. So if this is 12, that means this length left over from 16 would be 4. So my rectangle will be 5 times 12, so that'd be 60, plus I have to add on my triangle, which is 1/2, times my base here would be 5, because this length is the same length as this, times my height. And again, my height, we already said it was 4. So that would be 10. So my total area of this compound figure or irregular would be 70 centimeters squared. Again, highlight that. So when I'm talking about this, top, bottom of a trapezoid. Now for this first one, we're not given the height. However, we do have an angle. And height will always create 90 degrees, like so. And if I know that this top portion is 8 and this whole thing is 14, I can say that this little guy right here would be equal to 6. I also know that this is 90 degrees, so I have a right triangle. Oh my gosh! Remember how in day 3 we reviewed SOHCAHTOA and special right triangles? Remember how in a 45, 45, 90, whatever this leg is, this has to be the same length, so this would also be 6. Remember? Or else we could have used SOHCAHTOA and still got 6, using our opposite and our adjacent for TOA. But now I'm using my equation. I have 1/2 times my height is 6, times my top base is 8, plus the bottom base is 14. So you always want to remember that you're adding your two bases together. Sometimes people multiply them, and you should not do that. So my answer would be 6 millimeters squared. So I'm dealing with the rhombostric height. It's 1/2 times my two diagonals. The reason for that is because if you look at this with your diagonals, you actually are finding the area of 4 different triangles. And so your triangles would be 1/2 times base times height, and really the diagonals make up your base times height. So for this first one, it would be 1/2 times one diagonal, so this diagonal right here would give me 6, times my other diagonal right here would give me 8, so that would be 24 centimeters squared. This 22 is for the whole length, and this 25 is for the whole length. Now we get into tough stuff. So first we have to talk about things about an irregular polygon. In a regular polygon we have an apothem. The apothem starts at your center and it goes down and creates your 90 degrees with the edge. So that kind of gives you the height. Remember, the height always creates a 90 degrees. But when we talk about a regular polygon, we're talking more with the center of the circle. So when we're talking about angles, when you're looking at angles at the center of the circle, it makes a circle. And you should know that all the angles in a circle add up to 360. So depending on the actual size length, so if we look at problem 1, if I'm looking for this first angle, angle 1, I have 5 different angles. 1, 2, 3, 4, 5. Because I have 5 different sides. So I have 5 central angles. So if I'm looking for angle 1, all the angles should add up to 360, and I have 5 different angles. So angle 1 is equal to 72. Now your apothem will always cut your central angle, so that angle 1 is your central angle, in half. So if I'm looking at angle 2, I can cut that in half, and I would get 36. Now if I'm looking for angle 3 is this little guy right here. If you look, this gives you a triangle. Like I said, the apothem creates your 90 degrees, and we just found out that this is 36. So we could do a triangle, 180 minus 90 minus 36, and we would get that angle 3 is equal to 54. It's more important to be able to figure out what angle 1 and 2 are, whoopsies, than angle 3. But I want you to try to do B by yourself. Now, I would write this down when I find the area of a regular polygon. Perimeter, P stands for perimeter, so that would be the length around my shape. My apothem stands from the center of the circle, creates 90 degrees in 1/2. Because essentially, we're finding the triangles that are mated, or that was created by each of my pizza slices as sides, you might say. So officially finding the area. When you find the area, you will see me often draw a right triangle just like this. This length will be the apothem. This length is half your side length, because if I were to draw it on this shape, here's my apothem, and when I draw this right triangle right here, it's half your side length. Remember that apothem cuts the central angle in half, and it also cuts the side length in half. However, good news, we don't necessarily have to write that up for this problem, because we already have the apothem, which is 14.5. So I'm going to have 1/2 times my apothem, 14.5, times my perimeter. Now my perimeter will be equal to have 1, 2, 3, 4, 5, 6, 7, 8. 8 times however many side, or whatever the side length is. So 8 times 12 will give me 96. So I times that by 96. My area is 696 centimeters squared. So I want you to do B by, whoa, okay. Now it starts getting a little bit more difficult. So what if I'm asking for the area of a regular 18-gon with a radius 7 centimeters? So first I'm going to draw out my right triangle. The right triangle that's created with my apothem. This is my apothem. Radius is going to be your hypotenuse that is created with your apothem. So I'm going to put my 7 there. Here's my 90 degrees. This will be half your side length. Remember, the apothem cuts the angle in half, the central angle in half, and also the side length in half. So how am I going to do this? First I have to figure out what this angle is. If I do 360 divided by 18, that will give me my central angle. So that would be the bigger angle. But when you cut it in half with your apothem, so that would be equal to 20, you have to divide that by 2 because your apothem cuts it in half. So this angle over here is 10. I'm going to set up 2 different equations. One to find the apothem, that's my adjacent, and I have my radius, which is the hypotenuse. So that would be ka, so it's cosine of my angle, that's 10, is equal to my adjacent, ha. To get rid of this division, you have to multiply. So 7 times cosine of 10 would be equal to my apothem. And you should be rounding to your nearest hundredth. So this would be 6.89. If you do not get 6.89, you should make sure to check your mode. Now I have to look for my x value. So x is my opposite from my angle and still my hypotenuse. So it's going to be so sine of my angle is equal to my opposite over my hypotenuse. Again, to get rid of that division, you want to multiply by 7 over on their side, and that will give me my x value. So x is equal to 1.22. This is where you have to be careful, because x is half my side length. So if I'm looking for my side length, my side is going to be equal to 1.22 times 2, which is great, which will be 2.44. However, now I actually have to figure out what my perimeter is. My perimeter is one side length, 2.44, times however many sides you have. It's an 18-gon. 18, so times 18. If you can't tell, that was an 8. So my perimeter is equal to 43.92. So my area is 1/2 times my apothem, 6.89, times, I'm just going to draw an arrow, that, because I don't have enough rooms. 0.89. So your answer, I'm going to do this, will be, let's pick a new color, people, shall we? Good color here, rainbow, is 151.30. My units here was centimeters. So centimeters, come on, centimeters squared. That's my total area. I want you to try to do the next one by yourself. We'll be going over this in class. And I want you to have a great, grand, wonderful day. Just, keep smiling. Keep saying hi to people. Just smile and say hi.